This is number 1 on your homework of 4.1. Here we go. So they give you the equation y equals 5x minus 2. They tell you to graph it and determine if the given point is a solution to the equation, question mark. So the point is 1, 3. Okay. So you can graph it. There are 2 different ways to tackle graphing it. This is in slope-intercept form, so you can either just go, okay, my y-intercept is -2, and then my slope is just 5, which means it's 5 over 1. So I can go up 5, 1, 2, 3, 4, 5 over 1. And then I'll do that again, 1, 2, 3. Oh, I did not make this scale very well. 1, 2, 3, 4, 5 over 1. And then you could do the opposite. You could go down 5 over 1. So I can go down 5, 1, 2, 3, 4, 5, and then I can go over 1. Just like right there. And then you would connect all your points. That would be good enough, I think. Okay. And so then, is 1, 3 on it? Oh, actually it is. We graphed it. This is 1, 3. X is 1, y is 3. Oh, 1, 3. So, yes, it is a solution to the equation because it is on the line. You could have made a table. You can always make a table. Tables are your friend. Can you see this? Yes. X, Y. I don't know. I'd probably go like 0, 1, 2. When x is 0, 5 times 0 is 0, minus 2, -2, which is our y-intercept. Then 1, 5 times 1 is 5, minus 2 is 3. Oh, look, there's our point. Anyways, and then 2, 5 times 2 is 10, minus 2 is 8, which we actually graphed that as well, 2, 8. We're so good. Okay, so that's what you're doing for 1 through 6. Let me see if there's a tricky one. I'll pause you for a second. All right, here's number 5 because it has a fraction and y'all don't like fractions. So once again, you can either make a table, you can always make a table, or you can analyze the equation. Oh, I didn't write, this should be y equals, that's my bad. Y equals, this is number 5. Okay. Y equals 5 over 2x minus 7. So once again, this is in slope-intercept form, which is y equals mx plus b. That's your y-intercept, that's your slope. Okay. So I'm going to start with my y-intercept, which is -7. 1, 2, 3, 4, 5, 6, 7. And then my slope is 5 over 2. So remember, slope is change in the y over change in the x. So I'm going to, this also should sound familiar. Slope is also rise over run. So I'm going to rise 5 and I'm going to run 2. So I'm going to rise 5, 1, 2, 3, 4, 5, and I'm going to run 2, 1, 2. There's my next point. Okay, and then I'm going to rise 5 more, 1, 2, and then I'm going to run 2 more, 1, 2. So like right there. 1, 2, 3, 4. No, like right there. Ish. Oh, this is not going to be a straight line. We got to move it over so I can make it straight. Right there. Okay. And then, I don't know. We'll see if we need to plot more points. I'm going to start with that. Oh, I need that. So I'm going to connect our little dots, which I don't think I. Oh, no, we'll be fine. And it really continues on forever in both directions. Okay. So does the last one. It continues on forever in both directions. So we're looking for the point 2, negative 2. So if I look at my graph, when x is 2, y is negative 2. So yes, that is on our graph. You could also make a table. X, y, 0, 1, 2. When x is 0, 5 over 2 times 0 is still just 0, minus 7. Oh, look, that's our y-intercept. We already knew that. X is, I don't want to do 1. Let's do 2 and 4. So then you could do 1. It was just going to give me a fraction answer, and I didn't want to deal with it. So if x is 2, 5 over 2 times 2 is just 5, minus 7 is negative 2. Oh, look, that's our point. So it is on the graph. That's our point. And then 4, 5 over 2 times 1, it's going to be 10 minus 7, which is 3. Oh, we didn't plot that one. Oh, yes, we did. 4, 3, right there. Okay, so if your point is on your line, then it is a solution. If your point is on your line in your table, it is a solution to your equation. Okay, the last one I'm going to do is number 6. I'm going to pause. All right, number 6. Y equals negative 4/3 x. Oh, I forgot the point. And the point is 2, negative 5. Okay. So once again, you can make a table, or you can look at your equation. But you're like, Miss Bailey, there's no y-intercept there. That's true. Remember, your equation is y equals m, which is their slope, x plus b, which is your y-intercept. They didn't write a y-intercept. That means it's going to be 0. You can fill it in, or if you don't believe me, we can make a table. Zero, 3, 6. Oh, we're just going to do 0. Well, we'll do the table first, whatever. So then, no, we won't. We'll just do the y-intercept. So our y-intercept, if x is 0, what's y? I'm going to put 0 in for x. Negative 4/3 times 0 is, in fact, 0. So that means your y-intercept right here. Right at the origin. Boom. Right at the origin. That's your y-intercept. Okay, now you can use your slope to graph the rest of your line. So your slope is negative 4, negative 4/3. So you can go down 4 and then over 3 in the positive direction. So down 4, 1, 2, 3, 4, and then over 3, 1, 2, 3. Like right there. And then we'll do that one more time. We'll go down 4, 1, 2, 3, 4, and then over 3. 1, 2, 3, like right there. And then you can also go the other way, right? So you can go up 4 and negative 3 this way. So I can go up 4, 1, 2, 3, 4, and then negative 3. 1, 2, 3, like right there. Right there. Then I can draw a line, connect all my dots. Yes, I can. Oh, and once again, it continues forever in both directions. Okay, and then I'm looking for the point 2, negative 5. So when x is 2, is y negative 5? Well, that would be 2, -5, that would be like right here. So that, unless I drew my line terribly, which I didn't do that, then no, 2, -5 would be like right there. So it does not look like that is on our line. You can prove it to yourself. You can substitute 2 into your equation. So then, it's going to be a fraction answer. All right, so then you're going to have -4/3, and you're going to multiply it by 2. And so you can just multiply straight across. That would be -8. -4 times 2 is -8 thirds, which is 2 and 2 something like that. Hold on. Or you can leave it as -8 thirds. Yes, it would be 2 and 2/3. So is that a point? So that is where our point is. X is 2, y is like, yeah, right there. In between -2 and -3. So no, this is not on our line. No. No, that is not a solution to the equation. So if the point is on your line, it's a solution. If it's in your table, it's a solution. This one is not. This is the one, the 2, -5 would have been like right there, and that is not on our line. No, it is not. Okay, lay pause. We're going to move on to different types of homework problems. Number 10. Okay, this one is determine if the 2 expressions listed are equivalent. Explain your reasoning. Okay, so these are the 2 expressions they give you. 3 times the quantity w minus 9 over 5, and then they give you 3w over 5 minus 27. Are these equivalent? Okay, so I don't know, you can play around with it in a couple different ways. So one thing you can do is, I would start out by distributing my 3 and see what happens. So then that would give me 3w and then 3 times -9 all of that over 5. Okay, you can simplify that again. Well, yeah. So you can separate these guys out. So then you'd have 3w over 5 minus 27 over 5. Okay. We can stop because these 2 are not equal. This one, the first term matches, but then they got rid of the dividing by 5, so that's going to be very different. This one is just 3w over 5 minus 27, and here we're dividing 27 by 5, so those are going to be very different answers. These are not equivalent to each other. I mean, so you can play around with it that way. That's the way your book does it, and that's probably how I would do it. You could also do, like, okay, if these equations are equal to each other, then if I multiply them both by 2, they'll be equal. If I multiply them both by 5, they'll be equal. So I'm going to try that. So I'm going to multiply this whole thing by 5, and I'm going to multiply this whole thing by 5. All right. So this one, I'm divided by 5, so these guys just cancel each other out. So then I'm just left with 3w minus 9. On this one, I'm multiplying the whole thing by 5, so this 5 is going to cancel out. Boop. So I'm just going to have 3w. But then I have to multiply 5 times negative 27. Oh dear. Which is, hold on, let's see it. Negative 20 times 5 is negative 100. Negative 7 times 5 is 100 is 35. So negative 135? Maybe? Okay. Aha! Okay. So then those are not the same. Even if I distribute my 3w minus 27. No. So these guys are not equivalent to each other. No, no, no. Ow. Oh, you can also, shoot, I just erased it. There's so many different things you can do. Another thing, oh, that's the problem I just did. Oh, here it is. 3w minus 9 over 5 and, oh. If they were equivalent, then I could substitute in the same thing for w and I would get the same answer. You could do that. That seems like a lot of work. But there are lots of different ways you can play around with it. But the way they do it is they distribute the 3 the first way. So you get 3w minus 27 over 5, and that can break down into 3w over 5 minus 27 over 5, and that is not equivalent to that. Okay. There's no dividing by 5 on this one. I'm thinking. Okay, I'm going to do one more. I probably shouldn't, but I'm going to do number 13. I mean, you guys probably don't need it, but we're going to do it anyway. 13. 4x minus 2 over 5. Equals 4x minus 2 over 5 equals 20. Ooh. Okay, so these you're solving for x. Okay, there are 2 different things you could do first. You can either distribute the 4, or you can get rid of this 5. I'm going to get rid of my 5. So to do that, I'm going to multiply both sides by 5. 5. Because what you did to one side, you have to do to the other side. All right, on here, my 5 just cancel each other out. And so I'm left with 4 x minus 2 equals 20 times 5, 100. Now, you can either divide by 4 on both sides, or you can distribute. I'm going to distribute. So then you get 4x minus 8, because 4 times x is 4x, 4 times negative 2 is negative 8. It's 100. And now we're in familiar territory, so I'm going to add 8 to the other side. You get 4x. 8 minus negative 8 plus 8 is just 0. 100 plus 8 is 108. So then, oh, my bad. And then we're going to divide both sides by 4. Can you still see this? Oh, you can. Okay. So then x equals 27. Okay. There we go. Okay, for 16 through 21, it says indicate whether the given value is a solution to the corresponding equation. Show your work. So this is number 17. So they give me x equals 4/3. And so is that a solution to this equation? So you just take whatever x value they give you and substitute it in. So I'm going to substitute 4/3 in for x. So I'm going to have 3/4 and then substitute it in times 4/3. And then just rewrite everything else. Plus 1/2 equals 3/2. All I did was substitute 4/3 in for x, and then I just rewrote the rest of the equation. Okay? So that was over there. So then, we'll just do it. So you're going to multiply straight across. 3 times 4 is 12. 4 times 3 is 12. So that's just 1. And then 1 plus 1/2 equals 3/2. And so what we're saying is that true? Well, 1 plus 1/2 is 1.5. Is that the same as 3/2? Ooh, they're making you go back and forth between mixed numbers and improper fractions. Is 1 1/2 equal to 3/2? Yes. Yes, it is. Yes. So the answer is yes. Ooh, that was bad handwriting. So 4/3 is the solution to the equation. So let's go back and forth between, so to turn a mixed number into an improper fraction, you multiply 2 times 1. So I mean that's 2, and then plus 1. So you get 3. So you multiply the denominator by your whole number, and then add whatever's on top. So like if I had 2 and 1/3, I'm going to turn this into a mixed number. I go 3 times 2 is 6, plus 1 is 7/3. Okay, so I multiply these guys, and then you add this, plus that. And you keep your denominator the same. Ooh. So then if I had 5 and 2, I don't know, 5th. Okay, to turn it into an improper fraction, you keep your denominator the same, so you can automatically rewrite your denominator. And then you go 5 times 5 is 25, plus 2, 27. What about, now I just got off on a tangent, I'll do one more. What about 7 and 2/10? So you can automatically rewrite your denominator, keeping it the same. And then you go 10 times 7 is 70, plus 2, 72. Okay, which this one, you could also reduce these, but that's how you do it. But then I could also reduce 72 over 10. They're both even numbers, so I'm going to divide them both by 2. That gives me 36 over 5. Divide by 2. Just simplifying your fractions, and then you can't simplify any further. Okay, moving on. Enough of that. So that was number 17. I'm just going to keep going. So I'm also going to do we did 17. I don't know. We'll do 18. Number 18. Oh, they make you substitute that y in instead. Aha! Oh, never mind. It's not. Well, we'll just do it. So y equals 2. Is that a solution to the equation 2.5y minus 10 equals negative 0.5? Yes. Okay. So is this a solution? So don't let them, they're going to switch the variables up on you. They give you X's, Y's, W's, B's, A's. It doesn't matter what the variables. Sorry, phone call. But I didn't need to take it. I'll talk to her later. Doesn't matter what the variable is. Okay, you're still just going to substitute it in. Here, should I color code it? We'll make y green. Y equals 2. And that's y. Okay. So remember, you're going to rewrite everything except you're substituting in 2 for y. So I have 2.5 substituted in times 2, and then rewrite everything else. Minus 10 equals negative 0.5. Okay, and then solve it. So I have 2.5 times 2, 5. And then minus 10 equals negative 0.5. 5 minus 10. Oh. Is negative 5 equal to negative 0.05? No. Negative 5 is not equal to negative 1/2. No. So, no. Y equals 2 is not a solution. I'll do one more. Let's just do 21. If you understand it, obviously you can turn me off. So 21, b equals 5. So b equals 5. Is that a solution? 2. Okay, I'm glad I'm doing number 21, because this is going to confuse people. I should put it in a note on the homework. 6x minus 2 equals 4 x plus 2. Yeah. Does anyone see a problem with this? Well, they gave you, oh, this is 21, by the way, not 18. This is 21 now. I'm checking it to make sure I'm not just being, No, they give you b equals 5. Well, I don't see a b in this equation. So that's their mistake. So you can either just turn this into an x, or you can turn all these into b's. So I'll just turn this into an x. But then you just substitute it in. This is okay. You can either substitute it in right away. Actually, yeah, we'll just do that. You can also solve for x, but we'll substitute it in. So 6 substituted in times 5 minus 2. Is that equal to 4 substituted in? 5 plus 2. I just substituted in 5 for my x values. And then solve it out. 6 times 5 is 30. Rewrite the 2. And then I'm going to distribute over here. 4 times 5 is 20. 4 times 2 is 8. 30 minus 2 is 28. 20 plus 8 is also 28. 28 equals 28. Checks out. So yes. And that's it.